Welcome to the Energy InSites podcast, your source for the latest insights in deep retrofits, renewable energy, and energy conservation. Now, let's get to today's insights. Welcome. My guest today is an engineer who spent his career at the working end of energy, from recovering heavy oil to leading one of Canada's petroleum consulting firms to taking a heat exchange company deep into the energy transition. He thinks in whole systems. He's refreshingly practical, and he has a lot to say about how we store renewable energy and stop wasting heat. Lowy, Gunnewiek, welcome to Energy InSites.
Hi, Kevin. It's a pleasure to be here, and I'm looking forward to our conversation today.
Me too. We first got introduced maybe a year or two back through your work with L2 Tech and SolarWall. And I think that's a good place to start. But maybe let me back up a step. You've been in this space for a very long time. So I referred to you the other day as elder statesman, and
okay.
You have a lot of wisdom that you've accumulated over the years. So let's take the first couple of minutes and walk us through some of your trajectory in the industry, and then we'll get on to SolarWall.
Okay, sure. I started out life growing up on a farm, and I had always planned on being a farmer when I was a young guy. And I would say that contributed a lot to my very practical view of life, because on a farm, you get up every day and you make things work. And if you don't, you don't eat. Farming didn't work out for me. The monetary side of it was a little insurmountable. And so I did a career switch and went back to school in my mid-20s, and just coincidentally chose engineering. Turns out I actually enjoyed it a lot and was actually pretty good at it, and embarked on an engineering career. And during my engineering career, I was always focused on, let's say, finding ways to do things better tomorrow than we do them today. And that led me to really exploit, let's say, a skill and an interest I have in solving problems, all kinds of different problems, technical and others. And through that process, I learned how to build teams, because if you want to solve bigger problems, more meaningful problems, you need other people to help you, because one person can only do so much. And coincidentally, that led me into running companies, because a company is really just a big team out there doing things. And so I've run a number of companies over the years, focused on everything from oil and gas extraction, to engineering big LNG plants, to finding ways to reduce emissions from industrial plants, to improving energy efficiency in a lot of different plants. And I think a lot of my interest there was really rooted in my university experience in grad school. And during grad school, I went to the University of Waterloo, and I had a research term at the Solar Thermal Research Lab at the University of Waterloo. And that's where I got involved with SolarWall, and it was the topic of my thesis. And when I graduated from school, it wasn't really viable to make a living doing solar stuff, not especially when you had a wife and a couple kids. And so I went a different route, but here I am in, call it my elder statesman era. And I'm now working with Conserval Engineering, the company that sells the SolarWall technology. And I must admit, I'm having a ton of fun with it. I'm learning about the built environment industry in a lot more detail than I knew previously. But it's really a continuation of that theme of, that I focused on, of energy efficiency, reducing the impact of our activities on the environment. And certainly, in more modern times, we label this, the decarbonization of our energy systems. And so have continued to focus on that during my whole career, and it's kind of fun to be working where I am at this time.
No kidding. What a trajectory, and coming full circle from your thesis. So that's very rare for people to kind of write their thesis and then however many decades later, be working in the field that derives from it. So I would love for you to share a little bit more about that. Where was that technology at that time? Were you part of its genesis, or where was Conserval at that time? Because it's certainly come a long way, and let's get into that. And then I think you have some examples to share.
Yeah. So Conserval had already been working on the solar wall by the time I arrived at grad school. However, it wasn't what I would say fully commercialized. They had some, call it larger scale pilot installations and they were working, but nobody really understood how they were working. And through the University of Waterloo and my supervisor, Professor Terry Hollins, we got NSERC research grants to study the solar wall in more detail, to sort of really dig down into the fundamentals of how a transpired plate collector works. Um, yeah, you're pulling warm air off the surface of a plate, but what's really going on there? And so that's what I focused on. And so I like to think that I did contribute to the solar wall being a successful commercial technology. And 30 years later, I feel fortunate that that technology is still going, still very relevant to our needs today, and helping to contribute to move it along at this point in time.
Yeah, it's a really great Canadian success story, because now this company, these installations are all over the world in all kinds of applications. Um, you've got some material here that you brought to share with us, because I don't know if everybody's familiar with transpired plate collectors.
Right.
So in layman's terms, we're taking energy from the sun and we're turning it into hot air, and we're directing that into a building. But
Yeah.
we're doing more than just that with some of the systems that you've designed and been a part of. And I think I'd love to give you an opportunity to explain that in a little more detail, maybe show us some images, and let's talk about some of the success stories, because some of them are a little counterintuitive, particularly in the north. We do a lot of work in our program with northern communities. You classically think of it as extremely cold, and yet you can still get heat from the sun there.
Yeah, absolutely. So it maybe just backing up a bit, solar thermal air heating. Um, a lot of people don't really hear much about it, despite solar wall being a Canadian success story. And we have installations in 40 countries around the world, and as you mentioned, everywhere from way up north to actually there's even an installation down in Antarctica. So yeah, it's really pretty cool how broadly it can be used. Maybe one of the reasons why it doesn't get noticed so much is that there's no moving parts to it. It just sits on the outside of the building, and if you don't know what you're looking at, you probably don't even know what it is, and you don't
Right.
even know it's actively generating energy for you. So yeah, and why does it work up north? Well, it just needs sunlight, and working up north, it's even a benefit because you get a lot of sunlight that will reflect off of the snow cover and onto the solar wall. So it actually is a significant benefit. in terms of collecting solar radiation. So, and I think, I just like to mention, Kevin, maybe before I pull up some pictures of different installations and that, but um, we're currently looking at, let's say, extending the range of application of the solar wall. And typically it's been, sort of an instantaneous kind of usage of the energy generated. You heat the air on the wall, you pull it through the transpired plates, and it connects into the HVAC system of your building, and you use that heat right away. And then when the sun doesn't shine anymore, it's like, okay, I guess I'm reverting back to more traditional means of heating my building and bringing in the air that I need. But what we're exploring now is actually extending these systems and collecting the solar heat in the summertime and storing it geothermally, and then
Oh,
bringing it back in the wintertime.
wow. Yeah,
Yeah,
because I remember when we first met, the general idea was you're pulling it. Let's say it's a super hot summer day. You're pulling that heat up to the point of what the building requires, and then your dampers are sloughing it off essentially into the atmosphere, whatever excess you get.
correct.
So this is very, very interesting. Um,
Right. And
yeah.
and what we're even including in this idea, Kevin, is let's say pulling the heat off of the solar wall, upgrading it using a heat pump, storing it, then bringing it out and delivering that heat into the building with a heat pump again. And
Wow.
we think that is a really tremendous new opportunity. And you know, just think about the northern climate, the buildings in the northern climate. If you can store this heat, we need to think about the permafrost a little bit more yet.
I was just
But if we,
thinking that. Yeah,
yeah,
that you beat me to it. I was going to ask you that question. We have an issue with the permafrost in the north.
yeah,
Um, we're generally trying not to warm the ground there. So I imagine the storing it
right,
in a geothermal situation would be limited to certain latitudes, or longitudes, I should
yeah,
say, and then, but in the north, could you use an alternative method like the salt or sand
yeah,
batteries that are above ground in a insulated silo, or maybe even a hot water tank?
yeah.
For simplicity's
All
sake, would that work?
all of those things, Kevin, they can all work. And you mentioned phase change materials. We're exploring that as we go as well. And Um, we still need to do more work on the techno-economics of a phase change material in this application. Um, the idea of using a sand battery, if you're aware of the Finnish company Polar Night,
Hmm.
they've built big industrial sand batteries that they're using for district heating systems.
Yeah.
And I'd love to connect into that and augment their heating of the sand using a solar wall. And you get you get to the summer months up north, and we have wonderful long hours of sunlight, and being able to collect energy from that sunlight in the summertime and then making it available in the wintertime is just makes so much sense to me.
Yeah,
So
absolutely. Um, Not to mention, even on the water side, to be even simpler than sand in a way,
right,
a lot of the northern communities, just heating water is going off of natural gas or going off of diesel or very expensive electricity. Whereas it wouldn't
right,
be that much of a stretch to just get a larger tank that's insulated. The
right,
issue might be heavy insulation if it's outdoors or maybe in a shipping container, or whether you're able to do it indoors in a room. I'm not
right.
sure what the right approach would be there.
But just imagine if you have a community and every community is let's say, connected into a district water system, if you will. And you then create a significant volume of storage that you can heat up and make it available in the wintertime. And if you have reasonable electricity, um, you can now implement heat pumps as well to really augment that heat that you've collected in the water system.
Well, this is fascinating. We need to circle back on this offline because we have a number of communities that we're working with in the north that I think would love this idea.
Yeah,
So back to the basics. A lot when people think about solar, if you pull someone off the street, most of them think of solar panels. They think of solar photovoltaic, PV,
yeah,
collecting electricity from the sun and powering their home, and it's on the roof of their house. And people have different feelings about it. It's become much cheaper over the years. It's a pretty easy thing to do, all things considered, relative to other options. But still, we have a lot of people that aren't very familiar with this no moving parts, very, very
right.
stable, very durable solar heat. And whether you're heating water, whether you're heating air, whether you're heating glycol or some other, fluid that's not going to freeze. I'm a big fan. And I think more people need to know about this, whether you're a homeowner, an asset manager, a community leader, an elder, whatever. This is very low hanging fruit and very robust systems, especially for people in remote communities, because one of the critiques that we've heard time and time again is that they've brought in highly technical systems, let's say a heat pump, let's say a fancy heat
Right.
pump, and because that's all the rage these days, and I don't want to knock that at all. However, they often require a specially trained technician to maintain and service, and
Yeah,
that has been a problem. Even cogen systems in the north, we know of some examples where the systems have gone down and they don't have a local guy to
right.
fix it. They don't have the
Yeah,
parts to fix it, and then it's down for weeks or months, or it doesn't come back on, as we've
right.
even experienced. And
Yeah,
so having a system that's extremely robust that a local plumber could easily maintain, or even a handyman, let's say, um, open just makes things so much more resilient.
right. So, you know, many of our systems are just simply tied into the building ventilation system. Um, there's a bypass damper to bring in fresh air when it's really warm outside. Otherwise, you pull the air in through the solar wall. And some systems are as simple as, you got a polytube duct in the top of your industrial bay where the warm air is coming in. That's it. And to your point, really easy to maintain. Um, you're building HVAC system. People generally know how to make those work. They're not that complicated, and so yeah, it's quite simple to integrate in. You have an additional damper to modulate flow between the fresh air intake and the solar wall, and that's it.
Hmm.
It doesn't have to be any more complex than that.
So I think of it in terms of, for the listeners who haven't seen a solar wall before, if you've ever walked into a greenhouse on a
Yeah,
cool day, instantly, you notice that greenhouse is several degrees warmer, maybe tens of degrees warmer, and it's
right.
just the sun hitting that glass. You have kind of airspace, and now you're capturing that radiation into the space. Solar wall acts like that, but it doesn't look like a greenhouse. It's just this tiny building envelope addition, another layer like a jacket that you're putting on the building. And it's this action that happens between, let's say, your brick wall and the outside of your new material, which is typically metal, just
Right.
perforated
Yeah.
metal where you've got little
Yeah.
holes in it and the air is able to come through. It heats up the metal, pulls it in a draft fashion, and then you're controlling that flow into the ductwork. Is that fair to
Right.
say?
Yeah. Is it potentially time for me to pull up a little schematic to help
Yeah.
illustrate?
Let's help people visualize this so that they can see
Okay.
just how straightforward and simple this can be. And while you're pulling that up, the other thing that just occurred to me that might be of interest to some folks, we deal a lot in wildfire resilience, climate resilience. A lot of people are going through climate change. A lot of buildings, their building envelope becomes a pretty big ticket item
Okay.
to repair or upgrade. You have the whole spectrum from wood to vinyl to um, brick, stucco, whatever. And your system actually can act as an additional fire resilient layer because it's metal, because it's
Right.
non-combustible.
Yep.
To add that to the outside of a building can improve the resiliency of that building.
Yeah, and maybe before we get down into the details of the solar wall, to that point, you know, the solar wall, let's say, has other benefits. For example, you'll have heat loss through any building wall, no matter how much insulation you put on it. There's always some heat loss. And with the solar wall, you pick up that heat and return it back into the building. So that's a nice benefit. And in the summertime, when you don't need it and it's shut off, you're effectively adding additional insulation to the building, um, because you now have this dead airspace. Say it's 6 inches thick of just dead air.
Right.
And that's great insulation to help keep your building cooler. So it reduces your cooling load in the summertime as well. So yeah, it does have that benefit. And maybe one other benefit that is maybe not so familiar to everybody, but we've been installing a lot of solar walls on poultry operations,
Oh yeah.
and avian bird flu has
Right.
been an issue, as I'm sure you're aware. And we've had farmers, let's say, be infected in some of their traditional barns because the air inlets are pulling air directly in from outside. With the solar wall, you actually have now a coarse filter that you're pulling the air through. And they've seen barns side by side. One's been infected and one hasn't been infected. And they attribute that to the solar wall. It acts as a coarse filter for fresh air inlets. So
So the perforations are so small
yeah,
that they're actually
yeah,
preventing.
right.
So,
Yeah,
so,
and
wow.
the perforations are small, and because we distribute the airflow over a very large area, the flow rate through the solar wall is low, and so heavier material is going to drop out before it gets sucked in.
Okay.
So,
So and you're able to essentially mix in more fresh air
correct.
than just a 2 foot diameter hole in the wall. All
All
right,
right.
so here we are. We'd had a little technical break to get Lowy set up on his share screen, and we're ready to roll here.
Okay.
Great.
I wanted to just roll down to this slide here. And it really just, maybe I'll just skip ahead to the blow up here. And it just gives you a very, let's say, clear idea of how the solar wall works.
Great.
So on the outside of your building, and it could be a new build, it could be a retrofit, you can install the solar wall over top of it. And basically the sun shines. Now, why did it do that? Basically, the sun shines on the typically a black painted surface, although we do other colors. And when the sun shines on a black surface, I'm sure everybody's had the experience of putting your hand on a darker surface when the sun is shining on it, and it's warmer than the air around you.
Oh yeah.
And so that heats up the air on the outer surface of the solar wall. And then, as I mentioned before, we have all these little perforations in the solar wall, and they're quite small. Porosity for a solar wall is typically going to be in the 1 to 2% range at most,
Wow.
and we design them depending on the airflow that we're trying to achieve. And as you can see, we just pull her straight in. You can have summer bypass dampers so that you don't pull the air from the solar wall when it's hotter than you need it for your building. And you bring it into the building and use it where you need it.
And is it fair to say
So,
that this is an older drawing, because that summer bypass damper is where you might
yeah,
in the future tie that into a phase change or some other kind of energy storage
yeah,
mechanism?
yeah, absolutely. And for example, these days, heat recovery ventilators, energy recovery ventilators are pretty common. Um, and I would say the majority of new buildings are using some form of them. And we just tie directly into those units as well in the same way. And so you're picking up the heat that you're exhausting from the building, combining it with the solar wall heat, and putting that back into your building. So that's how that can work. And yes, to your point, if you're now pulling air from a stored source and bringing it into the building, you can do it in the same manner. Uh, so
That's great. So you can intertie an ERV into your system, and then they work in parallel and in a synergistic way.
yeah, yeah, absolutely. There's a building in Waterloo, Waterloo, Ontario, Canada, and that's called the Evolve One building, and it's Canada's first net zero building. And I think we have like 5,000 square meters of solar wall on that building as part
Oh
of
wow.
their goal to achieve that net zero. And yes, we tie directly into their heat recovery ventilator in this particular case.
That's amazing. So that's really a pretty, all things considered, and I don't want to take away at all from the complex physics and engineering that has gone into commercializing this over
Right.
30 years. But at its core, I love the simplicity. Let's
Yeah.
take a piece of metal, let's expose it to the sun, let's heat it up, and let's create an environment where air is coming in and it's warming up that air as a convective
Right.
method, and run it into the
Yeah.
building, and then use that as a
Right.
supplement.
It's a very simple, elegant solution. And, it because it's so simple, it really doesn't get the attention that PV gets. But, nonetheless, it's actually more efficient in capturing solar energy than a PV system as well. Typical PV systems are, say, 25% efficient at capturing solar radiation. Um, we run anywhere from 50 up over 80% efficient in capturing that solar energy, depending on how we're running the solar wall for the needs of the building.
Wow.
And so, um, you know, let's say a great way to capture that heat that's coming from the sun. And, one of the evolutions of the solar wall technology has been to combine it with PV actually and do PV thermal and mounting the PV panels over top of a solar wall, and you improve the performance of the PV systems because they are cooler and are more efficient as they're kept cool, and you're capturing the heat that the PV panels generate, and you use that in the building along with the solar energy you directly capture with the solar wall.
And they're kept cool.
Yeah,
They're
sorry?
kept cooler because the airflow behind it is pulling
Correct.
the heat off
Yeah,
of them.
yeah, exactly. Like you're now adding convective cooling to the backside of your PV panel.
Wow. You're creating kind of a non-stop airflow current that if it was
Correct.
just a rooftop solar system, you're kind of dependent on the wind conditions of the day.
Correct. Yeah. Yeah.
Right on.
So this is a nice little add-on to that, and yeah, there's been a number of systems installed, and I think as we continue to go forward, I think you'll see more and more solutions like that are combining PV plus thermal. A lot of it has to come down to do you have a use for that thermal energy, right?
Right.
So
And these days, there's a lot of North American sort of technology companies who design things here. I think of Silicon Valley. I think of Apple and all these companies that designed in Cupertino, and then of course made in China. And
right,
no knock to China. We all benefit from so much of their low cost products that we get. But increasingly with the tariff situation on aluminum, on steel, on the stress that's putting on Ontario and Alberta and all of Canada, this product is made in Canada.
it is. Now, I can't guarantee where the steel comes from because much of the steel is recycled. It's made in Canada. In fact, the metal that's used for the solar wall typically comes out of a Hamilton steel mill, and then it's rolled down in southern Ontario, and the holes are punched into it there. It's painted in Ontario, but for anybody who knows anything about the steel industry, metal is recycled all around the world. Steel is recycled all around the world, and so you can't quite guarantee where the steel comes from, but it's still very much a made in Canada product, invented in Canada product, and a very, let's say, successful commercial product that's been exported around the world.
And installed in Canada by Canadian contractors.
Yeah,
so, if you're looking
Canada,
for an interesting solution and a way to contribute to the retrofit industry or to your portfolio.
Right. There was an article published last year in the Canadian Architect Journal, and it spoke to the fact that Canada remains the leader in installing solar thermal air heating. And we have the climate for it, honestly. We got a lot of buildings to heat, and if we can do it using the sun, that's great. Great way to reduce the energy footprint of a building, the GHG footprint of a building. So.
Absolutely. So let's talk for a second about the different applications for this. I mean, this image you've got up on the screen could be anything. It's just essentially a box, right? It's your four walls. This is any building. If you've got some south exposure, typically, correct? South exposure, you can go to town.
Yeah. So I just skipped ahead here, and I'm going to start with just sort of highlighting the different ways that the solar wall has been integrated into buildings. And so here we've got a solar wall shown on this building here. and it's a fairly traditional solar wall, but it's been architecturally integrated into the building. So who would know when you look at this big tall building here that that's a solar wall? Um, but there you go.
Wow.
If we look at item 2 here, that's just our traditional single stage solar wall attached to the side of a building. Air is being pulled into the building and used in some manner. 3 here is what we call our two-stage solar wall. So the bottom of the solar wall is very much just a single stage solar wall, but then we bring the air back in at the top area of it, and we have a transpired plate over top of it. And so we're reheating the air that's been collected at the bottom. Why do you want to do that? We want to reheat the air because the building needs a higher temperature air in
Oh,
that
yeah.
there, so we can, let's say, double heat that air before it gets brought into the building. And we have an installation down in at the Plattsburgh Airport in Pennsylvania, and they made measurements on it, and we were seeing air temperatures being generated over 100 degrees Fahrenheit. Um, so what's that, about 38 degrees Celsius, something like that? So getting very toasty. So that's really quite cool. Um, Depending on the building and your application, there's a rooftop solar duct heating. So we arrange the solar wall on the roof, and they're connected to ducts that then get pulled off and into the
Oh,
building as well. It just gives you some flexibility if you have constraints or if you don't have a south-facing wall that you can use, etc. And the last one is the PVT. So you've got PV panels over top of a solar wall. And so now you've got a hybrid system that's producing both electricity and heat.
wow. And you can use this for heating air, but you can also use this for heating water.
Correct. Yeah. So we wouldn't heat the water directly, but you would use a heat exchanger in between or a heat pump,
Mm-hmm.
for example, where you take the air from the solar wall, put it through a heat pump, and then go through a heat exchanger to heat water. Um, Pretty straightforward.
Yeah. Air to water heat pump becomes a
Correct.
piece of
Yep.
the workflow.
Correct. Yep.
Amazing.
So I'm just gonna skip ahead, Kevin, if that's okay.
Sure.
And I just wanted to show some of the applications, some of the use cases that we've done over the years. So there's a few pictures here showing different installations on the side, um, but we're on commercial buildings, industrial buildings, ag buildings, office buildings, multi-residential, municipal facilities, schools, hospitals, airports, garages, pretty much any type of building. Um, you may notice there that we don't focus on residential houses, and it's really a question of scale, integration into the building, etc. Although, um, let's say I am looking at an installation on a residential building where we would again use the model of the solar wall collecting the thermal energy from the sun, storing it in piles that the house is built on, and the piles are filled with a phase change material, and then pulling that heat out at times when the sun isn't shining, nights, wintertime at nights, pulling using the summer heat. Um, so I think the application
Wow.
for housing will come. But traditionally, we've been on very large or larger size buildings.
So I just want to dig into that for a second. So you mentioned the house is built on piles,
Correct.
and the piles have a phase change material inside.
Correct. Yeah.
I'm not
So,
familiar with
so
that. I haven't. Is that common?
I wouldn't say it's real common. It's let's say it's an eco house that's been built here in Alberta, and it's a little bit of an experiment at this point, a demonstration, if you will. Most people build a house and they want to put a basement in it, rather than building the house on piles. But there's no reason why, you could use these piles in other places, and it's really just a storage system, right?
So we've
That,
seen screw piles being used more and more, but that's not what you're talking about, right?
um, yeah, actually pretty similar to a screw pile. Basically, you screw it down into the ground, but you then have that hollow pipe, if you will,
Yeah.
and you fill that with phase change material, and you connect the heat exchange elements into it, and away you go.
Wow. So then you've got some sort of manifold that they
Correct.
all connect back into that's
Correct.
independent of the floor joists that are
Right.
bolted to
Yeah.
presumably some other kind of gasket or you know shape
Yeah.
to the profile of the screw. So you got
Correct.
your foundation bolted down somewhere, but then in the middle of that you've got your hollow tube. So what's an
Right.
example of the material? Like,
So,
would that be glycol or
um, no, it would be a salt,
salt? Wow.
and in this in this particular case, the salt has a phase change temperature right around 45 degrees, I believe it is, and that's just, let's say, what was chosen in this particular design.
That's amazing. I've never heard of that before.
All right. Well, as a follow up, Kevin, I'll send you a link to this house. It's
Yeah.
actually a guy I'm working with that designed and built the house, and now he's living in it. So,
And assuming all your connections are good, um, what's the maintenance profile of that look like? What's the life expectancy of that?
well, I think that's what's currently underway at this particular time. As I mentioned, this is a demonstration project, and so let's say it's built with a lot more than just the phase change storage materials. It's got a lot of things going on in this house, and so it's trying out a number of new technologies, and really going for that net zero environment, and how to make that all work.
That sounds really, really interesting. I know I'm a bit of a nerd when it comes to technologies, and so I
That's
like to
great.
geek out on novel ideas. But it's not very often that I get caught off guard with something I've never heard about before. So
Well,
you've outdone me here, and this is why you're here. Or your
I'm
wisdom's
glad
coming to bear.
I'm glad I was able to do that for you. And I like geeking out on stuff too. And however, my geeking out always comes back to, well, it's gotta work in the real world. So
Yeah, well, it gets my mind going around the how much heat that can store and how long and how big the pipe is and how much mass that has and then how insulated that is, and the salt, of course, we think about being corrosive. So then what's the
yeah,
material of the connections and the pipe themselves to mitigate that? And so that opens up a whole other thing. I think I want to have that guy on the podcast to talk about his project, because that sounds
well,
extremely interesting. Maybe not for the faint of heart or the
I
average Canadian yet, but certainly a sign of
yeah,
things to come, I hope.
yeah, and look, my friend who's built this house, and Yeah, he's a little geeky as well, but he's also pretty practical, and so I'll make the introduction, and I look forward to listening to the podcast you have with him.
Thank you. Well, getting back to the primary idea here of solar wall, I mean, just
Yeah,
the number of applications, it really does seem to be virtually limitless.
right,
As long as you've got a wall of a building and you need some warmth or you need some
right,
hot water, you've
correct.
got something there to talk about. Now, one thing I'd love to get your opinion on, and we encountered this last year when we looked at a building that it's a new construction situation, and it has been engineered for the coldest day in the middle of winter in Alberta. And
Yeah,
so you size your natural gas furnace accordingly.
yeah,
And when we looked at adding solar wall to it, one of the challenges was, well, how does it perform on that coldest day? And therefore, how do you realistically, even if it could provide the heat the majority of the year for the majority of the building, you still run into this worst case scenario redundancy situation that makes it really hard to downsize that equipment. What would
right.
you say to, asset managers and building owners and operators who are interested in this and want to find ways to downsize some of their or fuel switch, and where to find that balance point, to model it out and to prove it out and to justify, a decision to maybe go for a smaller furnace or get rid of a natural gas appliance entirely.
Yeah. So Kevin, unfortunately, we all know that the sun doesn't shine at night, and it's usually coldest at night. And I like to stay warm in my house at night. So I'm not sure how we get along with the equipment sizing constraints. You know, I think I think along those lines, you do the best you can to let's say minimize your heat losses and minimize your heat usage or needs. And then if you can build into your building, storage elements. For example, uh, concrete floors do a great job of storing heat, or if you have a concrete wall and you can add in some heat storage into that, that's a way to extend beyond the daylight hours. But unfortunately, the solar wall only generates when the sun shines, and so we can't get around that yet. I don't know how to get around it.
But that is
So
where the new models of taking sand and salt and geothermal and some of these other things where you have these times of day or times of year where you're getting essentially an excess,
right,
you can really start to extend that
yeah,
runway out, level
right,
out those sudden swings.
yeah,
um, and you know I suppose the way I would frame it for folks is extending the life of existing equipment, justifying the additional the installation of a solar wall by reducing the need to change out, like you're not using the natural gas furnace as often, its cycle
right,
time decreases, its life expectancy increases, it's less wear and tear,
yeah,
those bills come down, your capital expense to get the system goes up a little bit for on a one-time basis. um, and then over time with the data that you collect, you may be able to start making some decisions. Certainly if you have electric as a backup or something like that, you might be able to um,
right.
use it
So
as an
so
emergency situation rather than your standard base load heat.
right. So I'll just share with you, feedback from one of the poultry farmers that I know that has a solar wall on his poultry barn. And poultry barns, you have to run them at around 20 degrees Celsius day, night, no matter what. Ventilation is incredibly important for a poultry barn because Otherwise, there's a buildup of ammonia and CO2,
Right.
and that's not good for the chickens. So you have to be moving air through your barn all the time. And he says he loves going out to the barn in the morning. Sun comes up. He can basically turn off his heating system for the duration of the day and run the barn on the sun's energy. And then at nighttime, when the sun starts going down, the building system kicks in again. And he said he just enjoys not having to burn fossil fuel all day to heat his barn. And so to your point, the hours of runtime on your conventional equipment goes way down, which means you have less maintenance requirements, longer life on all that equipment, etc. So there is payback in all of that, and typically we're finding that depending on, let's say, your building's heating needs, how you're using the heat, a payback on a solar wall would range in the, say, 1 to 3 years, fairly typically.
Wow.
Um, a
Certainly
solar wall's
better
not
than
that
most
expensive.
furnaces. If you had to replace one of those with a slightly higher efficiency than the one you had before.
Yeah,
I know a lot of people do get nervous about the topic of fuel switching.
right,
There's a lot of math between going from a sort of low cost gas to higher cost electricity, or your heat pump is more efficient, but the gas was so much cheaper. So yeah, the GHGs, if that's more important to you, then that, maybe you pay more. These debates are raging right now
yeah,
in every province,
right,
from single family all the way up to the biggest industries. But
right,
what I like about this is it's like a baby step to a fuel switch. You're fuel switching on a incremental basis without
right,
the wholesale. I'm going off the grid, or I'm shutting off the pipe.
yeah,
And so you have that kind of warm fuzzy blanket in your
right,
back pocket of like, hey, if it really gets cold and it's a dark day, like I've still got my boiler. But you also can feel good about just using it a lot less,
right,
and using the sun. I mean, my goodness, guys, we've got an infinite nuclear energy source here. Why not tap into
right.
that more?
Yeah, yeah, 100%. And I think even just looking back at this, on building construction, if you're doing a new building construction, you, you don't need to put on that normal external cladding that you would put on a building. Um, you just put the solar wall over top of your waterproofing and away you go. That's it.
Okay. So if we
So,
look at that for a second, if you're comparing the regular expense of your average cladding with,
right.
is it a premium? Is it a discount? Is it similar to just go straight to solar wall and kind of,
Um, well, we do have a special paint that goes on it, and
yeah.
we do have to put the holes in it. Um, and then when you install it, you need to seal around the edges so that it does what it needs to do. Um, but it's not that crazy expensive at all.
So a modest premium
Right.
for a one-time
Yeah.
turning something that is non-functional.
Right.
In fact, if anything, some of those envelopes are kind of a liability, or like, a deteriorating asset from day one, and you're
Right.
turning it into a productive asset on the building.
Correct. Yeah. I just had an installation last year where they put it on a building. It was a wood frame construction, so they did the normal stuff of, your wood frame, your insulation, and on the outside they just put their OSB board, Tyvek wrap, and then built a solar wall on top of that. So you no longer have the need to put another layer of galvanized steel on, or just roof steel on the outside of your building wall.
Amazing.
Yeah,
In our program, we deal a lot in deep retrofits. And
right.
so to those existing stock owners that are faced with having to redo their cladding at some point in the building's life,
Yeah,
this sounds like a good time to make that switch.
100%. It does make a lot of sense, and you know, even let's say I've had discussions with people that are looking at retrofits of existing buildings, and they've got all these glass walls, and they're looking at that and going, "Do you know what that does to my building cooling load in the summertime on this old building with, let's say, windows from the era of 15 years ago? They're not the same as they are today." And it's like, if I cover up some of those, I can generate heat in the wintertime and I reduce my cooling load in the summertime.
Right.
And it just makes a ton of sense, Kevin.
So you can even install a solar wall over older windows.
Yeah, 100%.
And I imagine in a single pane, maybe even the double pane, you're
Right.
getting a new kind of gain, pardon the
Right.
pun here,
Yeah.
by doing that. Of course, you lose the visual, the light transmission, but depending on the usefulness of that in that particular spot of a building, whether it's a warehouse space or something, maybe you need it, maybe you don't. Certainly replacing windows has gotten really expensive for high performance windows. Right. As a retrofit person, like, we never want to recommend people going backwards, go from triple pane down to single pane. I mean, that's just ridiculous. But certainly it's tough for people to make the decision to go up to a triple pane or a quadruple pane, as they even have available now.
And I'm sure you know how expensive they are.
Yeah. So on compared to new big glass windows that are high tech, how does solar wall stack up?
Yeah, so I'm not sure I have any technical details for you on that, the before and after. I'd have to go digging for that. I don't have it on hand today, sorry, but but just going back to that idea, I've been in some of the office towers here in Calgary, older building. In the summertime, you can't stand to be in the south-facing side of the building. It is just cooking hot. You even have the blinds pulled down, so you're not even looking at anything.
Right.
Why are you doing this? And then you've got the air conditioning pumping.
So suffice to say, if you're looking at the need to upgrade the glass, the fenestration on your building,
right,
it may be worth looking at these economics before you make that decision.
Yeah, 100%. And, you may not want to block off all of your view, but part of it. And, to the language that you used, you now have a working asset on the outside of your building.
Yeah, so I'm picturing some of those older downtown Calgary towers, those sort of C class, B class buildings that have, your average accounting. No offense to accounting, but just like your average kind of business, tenants.
How about your average engineering firm?
Yeah, not your AAA, not necessarily your AAA clients, but you've got these smaller investor owners who, and typically every floor has just glass all the way around.
Correct. Yeah.
So maybe like near the pillars or like on the corners, you're just like taking that off the board.
Correct.
And you're turning it into kind of an interesting facade. And then on the inside of the building, it's just another piece of drywall and is painted to finish.
Right. Yeah.
Okay. And would you also be encouraged, like if people are redoing cladding, whether it's fenestration or just, the standard siding or whatever needs to be updated, that they would also be adding insulation at the same time? Or
yeah, it would make sense to do that, wouldn't it?
Yeah. So you've had some examples of clients who are taking their cladding off. They're adding, 1, 2, 4 inches of insulation, strapping, whatever, and then putting your system over top of that.
Right. Yep.
Lots of ideas here. Lowy,
So
I want to thank you so much for your time today. This has been super insightful for me. I've learned a ton. I hope that
Yep.
other listeners will get as much value out of this as I certainly have. For those who want to follow your work or get in touch with you, what's the best way to get in touch?
Um, I don't have a website, but you can find me on LinkedIn. I use LinkedIn really as my website where I, let's say, demonstrate my journeys to date. And I have a very long email address. I don't know if you want me to do it on here, but
I'll tell you what, I'll
is that
post it in the description of the
okay?
video, and then people
Yeah.
can, and I'll give a link to your LinkedIn profile in the description of the video as well. Solar Wall is at solarwall.ca. What's their website?
Yeah, just type SolarWall into your browser and it'll pop up at the top of the list.
Right on. And you generally look after their folks in the Western Canada
Correct. Yeah.
area, right? Great.
Yeah,
Well,
but I'm not very territorial, so I'm actually promoting some SolarWall over in Europe right at the moment, but
amazing. Well, for anybody in the US or international that picks up and listens to this YouTube, reach out to Lowy, and you'll get all kinds of information and we can help you out.
yeah,
Thank you so much for your time today. I really appreciate it. And
my
I can't
pleasure,
wait to
Kevin.
have you back again in the future.
All right, sounds great. It's
Thanks,
been
Lowy.
fun and happy to share a little bit of this with your audience.
We appreciate you.
All right, take care.